Let's start this problem with a sketch. Okay, so say this is my x-axis and this is my y-axis. Okay, this is north, south, east, and west. According to question, first car is heading towards south. So say this is my first car over here, represented by this ball. It has mass m1 and initial velocity is v initial for the first car. Okay. The second car has mass m2. It is heading towards west with initial velocity v initial 2. So this is the case before collision. After collision, according to question, they stick together. So let's assume after collision, they move, they combine m1 and m2 and move with the common p, velocity p, and say the angle with the x-axis is theta. Okay, so this is the case after collision. After collision. Okay. So these informations are here. These are the symbol key. So careful here and here. First car is moving along y-axis, so no x component. And second car is moving along x-axis, so no component, no y component. Okay, so here plus and minus based on my coordinate system, I consider left negative, right positive, up positive, and down negative. Based on that, the coordinate system, these are the plus and minus. Okay, so now based on this information, you can see here that if I consider m1 and m2 as one system, right? If you consider one system, then no external forces exist. Okay, so no external forces acting on the system. So in that situation, in that case, I can write P1 plus P2 equals P1 prime plus P2 prime. We know this is the conservation of linear momentum. Conservation of linear momentum. This is the principle. For x-axis, we can write P initial for first particle, first object along x-axis, P initial for second object along x-axis must be equals to P final for first particle along x-axis plus P final for second object or particle along x-axis. Okay, so this can be written as m1 v initial 1 along x-axis, m2 P initial for first particle, second particle along x-axis, that must be equals to m1 P final for first object along x-axis, m2 P final for second object along x-axis. Okay. So here, similarly, we can say this is the initial momentum for m2 along x-axis, and this is final momentum for m2 along x-axis. Okay. Now we can plug the numbers that we have. So 1200 times 0 plus 850 times negative 17, that equals 1200 px plus 850 px. Okay, so px is the x component. If you look at the picture over here, it has two components. One component y will be py, and x component is px. Okay, this will be the same as defined here. So we can simplify further to get, this gives us for 14450, right? 0 plus that number equals to 050 px. Further simplification like that, I need to divide both sides by 2050. That gives me px equals this will be minus. Okay, this will be minus, so this will be minus, so px will be negative 7.05 meter per second. So we find the x component of the both masses after when they collide. Okay, we can write conservation of the linear momentum for the y-axis like this. So we can plug the numbers. So this will be 1200, this is minus 8 times minus 8 plus 850 times 0, that equals 1200 py plus 850 py. Okay, that gives me 9600 negative, that equals 2050 py. As before, if I divide both sides by 2050, that gives me py equals negative 4.68 meter per second. So let's go back to our previous problem. At the very beginning of the problem, this Vx is the x component and Vy is the y component. We can combine these two. So we can use, so we have draw the picture like that. So we have Vx is along the axis x and Vy is along the axis y. So the total is V. So we can find this P and theta. So we can use the Pythagorean theorem, right? So this gives us V squared equals to Px squared plus Py squared. So V will be under square root of negative 7.05 squared plus negative 4.68 square, which will be 4.15 meter per second. Okay, so we find total V in this scenario. So this V is the magnitude of final velocity of m1 and m2 because they are combined. So we can find the angle. So we can, from this picture, we can write tan theta equals, we generally consider mod Vy over Vx. So theta gives us tan inverse, just put the number, 4.68 over 7.05. That gives us theta equals to 33.57 degree. Okay, so our final answer we can write like this. The final velocity is 4.15 meter per second, which makes an angle of 33.57 degree as shown in the figure. So that represents vector V final. Okay. Based on this, you can try this practice problem too. You can follow the similar approach. Okay.